Hello everyone, today we'll be covering the topic of interest. This video is only a video on compound and simple interest and does not cover the more advanced aspects of interest like the specifics of borrowing and lending. It just focuses on the mathematical aspects of basic compound and simple interest. To start off this video, I will give you a brief definition of interest and how it works. Interest is a small percentage of money applied to the original money that is lent either by you or for you. So you can lend the bank money and they will pay you interest, or you borrow money and you have to pay the lender interest. So for a bank account, it works like you deposit a certain sum of money in a bank account and the bank pays you a certain very small percentage of the money every year. Often it is less than 1%, so gains from interest are minuscule in the short term and may pay off in the long term. Knowing about interest is useful not just for math class and accounting class, but also in everyday life. Interest can work for you, like in those bank account plans I mentioned earlier, but also against you. For example, if you don't pay back a loan in a certain period, they could charge interest on the loan, meaning you'll be forced to pay more than you signed up for. Interest also is applied to loans which are paid in installments. In any case, it is important to have a basic knowledge of how interest works. Interest can be divided into two categories: simple interest, which is a steady interest rate, and compound interest, where the interest rate is applied on the previous interest as well. In this video, I'll explain how each of these types works and compare them to each other. I will provide you the formula for both of these interest types, and in the end you should be able to calculate each type of interest in just about any scenario. I will also give you a Python program capable of calculating simple and compound interest for any amount of money, interest rate, and time period, just in case you want to do some quick calculations. Simple interest, as per its name, is quite easy to understand. This is when the same amount of money is multiplied by the same rate. Each year the interest is in effect. There are four variables in the simple interest formula. P, which is capital P, always capital P, stands for principal, or the starting amount of money. This is also known as the capital. R, or the lowercase r, always lowercase r, it stands for rate, the interest rate percentage. This is converted to a decimal. For example, if the rate is 10%, then R value would be 0.1. T, or lowercase t, is time in years because interest is usually applied annually. These three values are multiplied to get the total interest, not including the capital, earned on the capital, represented by a capital I. To get the interest for one specific year, remove the t from the formula. The interest rate is same for every single year, and t just multiplies it for every single year, and I will show you that in a specific example right now. Let's demonstrate simple interest with an example. Let's say we have $1,000 principal at a rate of 10%, and we deposit this into an interest plan of 10% for 10 years. Yes, I know I said that interest rate depositing into a bank account is usually very low, but this is just for the sake of an example, and because 10% and 1,000 are very nice round numbers. Usually they're a fraction of a percent though, like 0.01% or something like that. So in this case, we here have a table of interest for 10 years. So we start off with $1,000, and then for the interest for the first year, we multiply that by the rate, 0.1, and that would be $100 in interest. And the total amount of money would be the principal plus the interest, and that'd be $1,100 because we start off with $1,000 and now we have interest for 1 year. That's $100, and now we have $1,100. For the second year, we multiply the original capital or principal by the interest rate. We do not multiply the total by the interest rate, because that's for compound interest, and we will get to that later. We always, in simple interest, multiply the original principal by the interest rate. And now we keep doing that for every single year we get that. So for the second year, the interest is same. Third year, fourth year, as you can see, the interest for every single year is the same. So for the second year, we would again multiply $1,000 by the interest rate of 10%, that's 0.1, to get another $100 worth of interest. Now we have the total amount of money. The total for year one is $1,100. We add $1,000 of interest we earned this year, year two, to the total amount of money we had last year, and now we have a total of $1,200. That's the $1,000 we started off with, the $100 from interest for the first year, and the $100 from interest from the second year, and so on. We just keep multiplying that, and you can see 1,100, 200, 300, 400, 5, 6, 7, 8, 9, 2,000. And if you multiply I equals PRT for 10 years, so you would get a total of $1,000 in interest. $1,000 times 0.1 would be 100, and multiply that by 10 years, that would be 1,000. So the total amount of money would be $2,000 because you have $1,000 of amount of money you started with, $1,000 you started with, and then another $1,000 of interest over the period of 10 years, and that would be a total of $2,000. So yeah, I hope I explained it clearly. That's just simple interest, but if you don't get it yet, please feel free to rewind the video or drop a question in the comments. But for now, we are moving on to compound interest. So that was simple interest. Compound interest is totally different though, actually, yeah. It's harder than simple interest, but not as hard as people say it is. The only difference in compound interest is that the interest you earned in the previous years is included as a part of the principal for each year. For example, in year 2 of the example scenario, the table I showed you last slide, you would multiply the original capital, $1,000, by 10% to get $100 of interest of that year. But for compound interest, though the first year is always the same as simple interest, first year interest, with the same specifications, the same principal and interest rate, of course, you would add the $100 of year one interest to the principal, $1,000. That would be $1,100, $1,000 of principal plus $100 of interest. That would be the principal, and then you would multiply that total by 10% to get $110 of interest for the second year. And for year 3, you would add that $110 to the $1,100. That would be $1,210. Multiply that by 10% to get $121 of interest for that year. Add that to the previous sum, and so on. I'll explain that in a table, just like simple interest. Yeah. I'll also explain the formula after the table because developing the formula for compound interest is a little bit difficult, and I'll show you how. So here's the table for compound interest. We have the same specifications, and we're going to go about this in a slightly different way than we did for simple interest. So for simple interest, we had the interest first, and then we added the total amount of money. But here it's easier to do the total amount of money and then subtract the interest from that. Subtract the total capital and the previous interest from that to get the interest for that year. So for year 1 or year 0, what you start off with $1,000, that's original capital, and you have $0 interest. For the first year, you start off with $1,000, you multiply that by 1.1 times instead of by 0.1. That's to get the total amount of money. So for multiply by get to the interest, you multiply by the percentage. That's 0.1 in the case of 10%, or like it would be 0.05 for 5%. But at that 1 right here, that basically means add 100% to that. So you would add the capital to the rate. So basically the interest is just a percentage of the capital. So the capital is always going to be the 100%. Any number is 100% of itself. So you multiply the capital and the interest rate to get 100 plus 10% to get 110%, which is also 1.1 times the number. So to get the original total amount of money, you have the capital, that's $1,000, and then $100 worth of interest. So you would subtract that to get $100. That's the same for this year. Year one is always the same as simple interest. But year two onwards, that's where it gets a little bit tricky. So you have that total. The total you got, the total money. That's $1,000 plus $100 worth of interest. You multiply that by 1.1 or 1 point whatever percentage you had. In this case, it's 1.1 and you get 1,210. You would subtract the interest you earned from the previous year plus the capital to get $110 worth of interest for that year. So in year one, you had $100 worth of interest because you were multiplying $100 interest here. And then this year, you had $110 worth of interest because this time, the year one interest, $100, was added onto the capital. And then you're subtracting that. That's the interest just for year two. The total amount of interest you had for year one and two is $2,210. And then you would add that interest onto here. $1,210, the total sum. Multiply that by 1.1. You get $1,331. You see how it's just going in that way, and it's gonna become decimals really quickly. So that's gonna be really impractical because banks and money, they only work to the hundredths place, that's cents. So generally they'd either round it up or down to the nearest cent. So that's why the numbers might be a little imprecise, but not by much. So basically, compound interest is you add the interest from last year and every single previous year onto the interest rate, onto the capital, and then you multiply that total amount of money you had by the interest rate. The total amount of money you earned, including the interest, including all the interest plus the capital, then you multiply that. And here's a shortcut I noticed, especially for this. It's pretty obvious for this scenario, although I'm pretty sure it should work for any other scenario. The interest gained for the year is the previous year's total sum divided by the rate decimal times 100. So like for a rate of 10%, that's 0.1. Multiply the total by 10. That's a mistake there. It should say multiply the total by 10. So, or yeah, divide the total amount of money by 10, yeah. So for a total amount of money, $1,100, divide the total by divide this total for the previous year. That's $1,000. Divide that by 10 is 100. $1,100 divided by 10, that's 110. 1,210 divided by 10, that's 121. 1,133.1. 146.41, and so on. See, $1,000. You start off with $1,000 before you multiply the interest, and then you divide that by 10 to get 100. Let's say the interest rate was 5%, and you would be instead 1,050. So the interest for that would be just, well, $50, because you divide that by yeah, that's, you just divide it by the rate. Anyways, I might be rambling on a bit. I hope you more or less understand this concept. The general point you have to understand is you multiply the total amount of money you earn by the interest rate. So it's easier to get the total amount of money first and then subtract the capital from it to get the interest. So I'll show you the formula first. Later. Right now, actually. Sorry. So developing the formula. Recap. All the previous interest is added to the capital. There are three formulas you might want to know. I made up these formulas. I'm not sure, and I'm pretty sure they do exist. I'm pretty sure compound interest formulas do exist, but at the time of making this video, I did not know if there was a formula or not, so I had to make my own formula. So there are three of them. Here's the formula for the total amount of money. So time equals principal times rate plus 1. Remember what I said before about multiplying the capital is rate is basically a percentage of the capital. So plus 1. The 1 is 100% in this case. So to get the total amount of money, you would multiply the principal by the rate and then add the principal itself. Basically multiplying the amount of money by principal plus 1 point rate. And just exponent that to time, because go back here, exponent that to here. So the relation you might not have noticed is this is $1,000 times 1.1, and what you're multiplying this is $1,100 times 1.1 equals 1,210. But remember here, 1,100 is already $1,000 times 1.1. So this total 1,210 would be basically like saying 1,000 times 1.1 times 1.1. In other words, 1,000 times 1.1 to the power of 2. Notice 2 is the same as here over here. This is the same thing again. That's 1,210 is equal to 1,000 times 1.1 times 1.1, and you're multiplying by 1.1 again. So that'd be like saying 1,000 times 1.1 to the power of 3, and see the year 3 over here. That's just a shortcut I noticed. Although a lot of people might have noticed that if they work with compound interest. So going back to the formula here. Yeah, so that's how you develop the formula. So if you want the interest for the current year only, what you would have to do is multiply the principal by the rate plus 1 to the power of time, and then basically the interest for the previous year is that to the power of time minus 1. So back here, see that? 1,331 is 1,000 times 1.1 to the power of 3. But the interest rate for the previous year, that's year 2, is 1,000 times 1.1 to the power of 2. So what you'd be doing to get that previous interest is subtracting the interest for year total for year 3 from the total for year 2 to get the interest for that year. So it'd be like saying 1,000 to the power of 1.1, 1,000 times 1.1 to the power of 3 minus 1,000 to the power of 1.1 to the power of 2. Yeah. And of course, for getting the total amount of interest, that's for every single year, all you'd have to do is subtract the capital. All the interest for any case is just the total amount of money minus the principal. You won't be getting the interest for that year, you'll be getting the interest for every single year the interest formula is in effect. So here is a table of the values over here. T is the total amount of money, C is the interest earned over the time period only for the final year, and I is the total interest earned over time period, not including the capital. And these are the values you learn from simple interest. And now we're getting to the tail end of this presentation. You notice that, in other words, compound interest is a lot better than simple interest if it's working for you, but if it's working against you, not so much. See, if I didn't mention earlier, the problem with compound interest is that you'll have to round it off. So it might not necessarily be precise, but yeah, anyways. Notice that compound interest is an exponential relation. As I said, you multiply principal times rate plus 1 to the power of time. You don't see an exponent in the simple interest formula. That's why the graph curves. Exponential graphs curve, like upwards or downwards. In this case, it curves upwards. Notice it curves. The curve is very slight because the interest rate is still pretty small, and the percentage you're multiplying is pretty small, but it still curves. There's an obvious difference. While blue, which is simple interest, is a straight line. You notice how, as early on, there's not much of a difference, but over time, you see there is a difference. Compound interest accumulates a lot faster than simple interest does. You see that gap right here? Right over here, it's like middle of total money would be like 2,500 and something. I don't know the exact amount. Forgot it. I don't care. Go back to the table if you want to see. But it's the total amount of money is hasn't increased a lot. It's only increased by 1,000. Blue simple interest is a linear relation, while compound interest is an exponential relation. And yeah, so I hope you enjoyed this video and got over my rambling. And that's it really. If you have any questions about compound interest and simple interest, as I mentioned before, I am happy to answer them on my YouTube channel. Just drop a comment in the comment section. And as I promised earlier, there's a program I made that can calculate compound interest and simple interest for any amount of money, any principal, any rate, and any time period. So yeah, just download the link in the description. If you already are familiar with Python, you can use it in a Python environment like the native Python IDE, PyCharm, Wing, or any other IDE, or you can use it on a website that's online like onlinepython.com. All you'd have to do is paste the code straight into the IDE or just upload the file straight to the environment. So that's it, folks. Like and subscribe for more content. Stay tuned for more videos. I hope you enjoyed this video and have a great day.